Hello everybody, just another example from class on what we talked about today. We were trying to learn how to classify rational numbers. The standard in the state of Texas for this is 6.2a. Students will classify rational numbers using a Venn diagram, and when they say Venn diagram, it could be a traditional Venn diagram or it could be nesting boxes, as you see here. A group within a group within a group, and students have to be able to look at rational numbers and integers and whole numbers and know which category they belong in. So they can't classify a rational number unless they know what a whole number is and what an integer is as well. So today what we did was make a foldable, and they ended up gluing this into their journals. So when it's time to study, this one looks a little different, but when it's time to study, they've got the foldable in the journal that's glued in, and they can study it. But basically, the content that we have on the inside is the three categories. So we started with whole numbers because they're the most common. And then that's what the students will recognize first. And we talked about how whole numbers are the natural numbers, including zero. So natural numbers would be sometimes called the counting numbers, like 1, 2, 3, 4, 5, 6, 7, and so on. A more mathematical term for that instead of counting numbers is the natural numbers. But whole numbers get their own name when you include zero in that set. So whole numbers include zero, and all the positive numbers after zero on a number line. So we drew a list, we drew a number line, and we noted that we're talking about all positive numbers including zero, and we just put some examples of numbers, and we just, we had the kids call out numbers, and obviously they always like to do really, really big ones, but it doesn't matter. If it's a positive number and it comes after zero, it is a whole number. The next category that we started learning about on the second day of school was integers, and integers are the natural numbers and their negative opposites. So everything past zero in the positive direction and everything past zero in the negative direction. So either up or down from zero on a vertical number line, or left or right on a horizontal number line. The kids like to throw out the term infinity because it's just a neat concept to them. So we talked about how that was from negative infinity all the way to positive infinity. Every number in that set are integers. If our number line continued forever, we would be talking about a lot of integers in that set. So we made some more examples down here, which looks a lot like what we had here, except now we're including the negative set of numbers. So integers kind of double what the whole numbers are because they include the negative opposites. Then we started talking about the ones that are a little more tricky, the rational numbers. And rational numbers are any number that can be written as a fraction. So it may not be, but if it can be, it is a rational number. And fractions are decimals and decimals are fractions. So if we say it can be written as a fraction, then we know that it can also be written as a decimal. Students learned yesterday, we wrote in our journals that fractions are decimals and decimals are fractions. We talk about the word rational and how it has the word ratio inside of it, and about how that's what a ratio is. It is some number over another number. We did some ratios in class. We said, out of 27 students, 4 of them had red shirts, so 4/27 was our ratio, and 4/27 is a rational number because 4/27 is a fraction. And if we did the division, we would get a decimal number to prove further that it is a rational number. A good illustration was to do a number line and talk about how rational numbers are the numbers between these integers on the number line. So between our positive and negative numbers, these other spaces in between, those are the rational numbers. Where half lives and where 1 2/10 lives, and negative 1 7/8, whatever it may be. The numbers between the numbers is kind of how we talked about that, or the numbers between the integers. And then we included some examples at the bottom. Some of them we put in fraction form and decimal form. This one obviously was a mixed number. We talked about how the number 8 by itself can be, as we stated up here, it can be written as a fraction. All we have to do is write it 8 over 1. And now, all of a sudden, what we thought was only a whole number, we realize is also a rational number. And then we talked about how rational numbers include positive fractions and decimals, and they include negative fractions and decimals as well. So another set of numbers that include the positive and the negative numbers. Why would we want them to know this? Why would we want them to be able to classify them? Well, they're going to be asked questions about this on tests that they're taking, and whether or not they can classify where they go. And so this is an example of that over here. This is the release STAR test from 2016. And this question right here says, which graphic organizer correctly groups the following numbers? 3 4/10, -2, +3, -1 2/10. And so you can see almost the same exact idea. Each answer choice has some nesting boxes or a Venn diagram that we're trying to fit them into. And let me show you one more example. So as we work throughout the day and throughout the weeks to come, we might come across some numbers that are answers to other problems that we might be solving. So we could be working on something and come across a solution that is the number 3. And so we can put it on a sticky note and we can say, hey, let's go back to what we were talking about classifying numbers. Where does 3 belong? And so we know that it's a whole number, so it fits within the whole number nesting box because it's one of those numbers that we would get to just by counting, starting from 0. We know that it could be written as 3 over 1, which is also 3.0 or 3.000 as a decimal, which is a rational number. So when we come back, we can see that 3 is a whole number. It is also included in the integers set, and it is also included in the rational number set. So it is a group within a group within a group. But then we have numbers that are different, like -17, for example. So once we get into a negative integer cannot be a whole number. So that's why -17 is outside of the whole number group, but it is still inside the integer group and the rational number group, because we can write it as a decimal and we can write it as a fraction, which makes it a rational number, and it is negative, which makes it an integer. And then we have some that are rational numbers only. So 1/3, for example, which equals 0.33 repeated. It is part of a number. It is not a whole number, and it is not an integer. So it is alone in the rational numbers nesting box. And so you can see that 0.75, which is equal to 3/4 or 9/12, is also not an integer and not a whole number. So it exists in that group by itself. So as the year goes on, as we come across different solutions and different numbers, we can throw them up there and classify them so that students get better at putting them where they need to go. Because we know that ultimately they're going to have to do this not just on the STAR test, but they'll have to do this on some unit tests, and they'll have to do this on some district tests. And so the Foldable seemed like a good way to get them to remember how to classify them, and like always, have them come and view this if they need to remember where to put these things and how they go. And hopefully this helps your students, and we'll see you next time.